So what happens when your initial velocity is given in terms of a magnitude and an angle? In this case, we're going to have to use a little bit of trigonometry, and that's it. We have to break that vector up into coordinate directions. So we're going to break it up into an x velocity and a y velocity, and we're just going to use trigonometry. So if we wanted to solve for this part of our triangle, we would use the cosine law. Cos theta is equal to adjacent over hypotenuse. And in this case, cos theta is just equal to Vx over the magnitude of our original vector. And so rearranging, we've got Vx is equal to the magnitude of our original vector times cosine of theta. Another way of thinking of that is Vx is the projection of our velocity vector onto the x-axis. So if you imagine that there's some sort of light shining above this vector, this would be the x projection, so like a shadow cast on the x-axis. In the y direction, we're going to do the same thing. But in this case, we're looking at the opposite side to our angle. So we're going to use the sine ratio, opposite over hypotenuse. In this case, opposite is going to be Vy, and hypotenuse is the magnitude of our original vector. So Vy is just the magnitude of our vector times sine theta, and that's like the y projection of our vector. So imagine now there's some sort of light shining in this direction, projecting our vector like a shadow onto the y-axis. So this is how you can think of breaking a vector down into different components.